Hello students, in this video we're going to introduce the core mechanic of our game, physics-based movement. Our probe, when we fire our thrusters, will be able to accelerate or speed up. It will increase its speed and increase its speed as long as we're firing our thrusters. And the moment we let go of our thrusters, the acceleration will stop. But the probe will not stop moving. The probe will continue to move with its velocity under its own momentum, slowly drifting off into space. However, it will not drift forever, as we'll introduce drag or some type of friction to eventually slow the probe down. This will leave our movement controls feeling rather slippery, which is exactly what we would want for a space-like survival game where our probe has to maneuver through an asteroid field. So let's head to the computer screen and let's dive right in. So I have lesson 3's starter file open here in vscode.dev. I'm going to minimize the browser and let's open this file directly as well in the browser. So I'll come right over to my Astro Drift folder and I'll open up lesson number 3. And let's see what we got here. So it looks like in our HUD we've got some indication that we should be able to press fire to press the spacebar to fire our thrusters. And so when I press the spacebar, nothing, nada, a completely broken system. And so it's our job over these next 8 missions here in this lesson to fix this system so my little probe can drift through the stars that we have created for him. Or her. So let's head to the computer screen and let's dive back in. Mission number 1 says we need to add the thrust input key constant. All right, let's do a Control F to bring up our search bar and we're going to go to mission 1. Mission 1 right here, our next tag going down is in, where are we? Oh, we're in the student edit zone. So this is something that is safe to modify. You can use whatever you want, but I am going to define our control scheme here as a specific button we use to fire our thrusters. And so right now it is set to a value of 44. I don't know what 44 is, but I know that it is not the space key. It is not the key code for space. So right here we have a little comment that says 32 is the key code. So hey, let's put 32 on. Beep, boop, 32. Awesome. So now we are mapping the space bar to this variable key thrust. So how are you supposed to know like what the key values are? Well, it's actually kind of nice. You can just look them up. If we type JavaScript or JS key codes, let's open up the first link that pops up here. All right. So if I open up the first link, it says press any key to get the JavaScript event key code info. I don't know. What's L? Oh, L is key code 76. Boop, boop, right here. What is space? Hey, space is 32. I said here. Look at it. It's right nice and big here. There you go. What's the shift key? 16. Caps locks is 20. Tab is 9. W is 87. 3 is 51. So we've got all these different key codes. All right. So that's kind of neat. Whoa. Square brackets. 221. That's a nice number. So now we can map any button combination that we want. But we are going to use a key code of 32 for our space key to fire our thrusters. Mission 1 is complete in the books. Well done. That brings us to mission number 2, because right now, even though I've mapped it, I don't think I'm going to be firing any thrusters, and I am unfortunately not. I want to move this ship. This poor ship has just been stuck in the middle of our screen for so long. It's time we get them moving. Perhaps it is mission 2 that will get us there. Mission 2 is all about updating some brand new systems that we are bringing into our game. So mission 2 finds us in the draw function. Remember, this function runs every single frame of your game, and it is called automatically by the P5 library that we are bringing in. Now, it's weird because I know that this is called draw, but really this is like our update functions. Because where are we drawing? Well, we're drawing when we call draw scene. See, we write all of our own draw functions way down here where we're drawing our background, our player, our HUD, and our overlays if certain conditions are met. So because our built-in P5 function draw is called every frame, we put all of our updates in here. Because remember, our game development pyramid involves 3 things. It involves defining data, drawing data, and updating our data. And we want to update our data every single frame, which is why this function works wonders for us. So we've got 2 new systems. So what are we doing in here? Well, if the current game mode is equal to play, right? We ask that question. We update our thrusters directions. Boom, we're doing that right now. We did that in our first lesson. But now it looks like we've got other systems we want to update. We want to update the thrust system, and the drift system. So there must be functions for this. And if you look, we're also doing something else in here. We're now checking if the player is lost in space. So let's scroll through our code and let's see what new functions we might have available to us here in this lesson to work with. So I'll scroll down. All right, so we got reset game to defaults. All right, we know what that does. That sets everything back to their beginning values. We have our update thruster direction, which we worked on together in, I think it was lesson 1, right? We set those values. And then look, here's a brand new function called update thrusters. All right, so that will help us update some of the data associated with our thruster system. It looks like we've got some missions in here to work with. And then we've got update drift for our drifting system, so that's pretty good. We got to update that. And then here is our check if player lost in space function. So all 3 of those brand new functions have missions in them, and all 3 of them need to be called inside of our draw function. So right now we're only calling one new system, and that is the check if player is lost in space. So let's call our other 2. I'm going to call update thrusters. So if we look here, update, if I hit tab right now, I'm going to get update thruster direction. I don't want that. You got to make sure you have the right one selected. So update thrusters. Right, there we go. All right, so now that function is going to get called. And what was the other one we needed to update? Oh, right, our drift system, because our probe, once we stop, using the thrusters, the probe is going to just drift in the direction that it is currently moving in under its own momentum. Now, if you don't know what that term is, don't worry. We're going to discuss those pesky physics terms here in a moment. But for right now, we're going to just call update drift. All right, it looks like mission 2 is all set. We are now calling all of our new systems. We're updating our thrusters, updating our drift, and then we're going to check to see if our player is lost in space. Is this going to work? No, of course not. You saw what those functions held. Those new functions are like empty. They're broken. We have to go fix them. So we're calling them, but boy, what we're calling inside of those functions is no good. So that brings us to mission number 3. Let's take a look at it. Mission 3 is inside of the update thrusters function. We know we're calling it. We're calling it every single frame of the game. What is the first thing we do? We are asking a question. We're asking, hey, is there a key that is down? Now, we have previously worked with key pressed. Key pressed is a P5 function that checks to see if a individual key was pressed down, right? It was unpressed and now it is pressed. That will check that button press. It doesn't check to see if something is held down. Well, this is where our new function does. Key is down is a built-in function that checks to see if a specific key is being held down. What key are we going to check? It is key thrust, our constant variable that we had set to 32, which maps directly to the space bar. So we're going to check to see, is the space bar being held down? And if it is, if the answer to this question is yes, then what do we want to do? Well, we want to provide some acceleration. It says, apply acceleration to the player velocity when thrusting. Push the ship opposite the thruster direction. Whew. Okay, so this is a little loaded, especially if you are new to terms like acceleration and velocity. So we got to describe what these terms actually are. And to do this, to help with this, we are going to go to our whiteboard. So we're going to do a little bit of physics here. So we're going to introduce a couple of terms. We're going to introduce 3 terms of motion right now: position, velocity, and acceleration. And to help us, we're going to draw some graphs. So imagine I have just a number line, and I don't really need any numbers on it, but I just have intervals on my number line. Boop, boop, ba-doop, 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 boop, boop. All right. And so here is an object. We have an object at a certain position. Okay, maybe I will put numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. How do I get this object right here, which is at position 0, to change its position? How do I get it to change its position? Well, in order to have an object change position, you have to give that object some velocity or speed in a given direction. So let's just say for this particular object here, I'm going to give a velocity v of, let's give it a velocity of positive 1. So what that positive sign is going to do is it's going to move the object to the right. So every time we have a snapshot of movement, or the object can undergo movement, this object is going to move 1 unit to the right. So it moves, bloop, 1 unit to the right. And the next snapshot, it moves 1 unit to the right. And the next snapshot, it moves 1 unit to the right. And the next snapshot, it moves 1 unit to the right. Of course, the velocity can change. So what if we change the velocity? We say, okay, we're no longer going to have a velocity of positive 1. I'm going to change its velocity. Maybe its velocity right now is going to be -2. So what does that mean for us? Well, the negative sign means we are now going to move it in the opposite direction. So opposite the direction we were moving in. So instead of going to the right, we're going to go to the left. And now instead of moving 1 unit, we are going to move 2 units. So let's just take a look. I'll grab a different color here. So now I was here. Now I'm going to go 1, 2 units back and 1, 2 units back. Perfect. So if we want to move our position or change our position, we have to have some velocity. That velocity has both a size and a direction. A size and a direction. But if you notice here, in each of these instances, the velocity is staying the same, right? If I just kept moving this blue object, let's go back to the blue object because it's easy. If I just kept moving the blue object, you know, the next time he's going to be here, then the next time he's going to be here, then the next time there, and there. At every interval, we are just moving positive 1 step. That is not always the case. Sometimes the velocity can change. Sometimes we can speed up. We can start slow and speed up. And other times we can move really fast and slow down. So how do we show those changing velocities? Well, to show changing velocity, we need that third quantity. That third quantity known as acceleration. An acceleration is a change in your velocity. It could be a speeding up. It could be a slowing down. So now let's throw an acceleration into the mix. I'm going to draw my number line. Okay, so here's my number line, and I'll just put 0, 1, 2. I'll draw this number line out for us, and we're going to pick some starting velocity. But we're not going to keep that velocity the same, okay? We're going to increase it based on some acceleration value. All right, let's see. Oh, I can count 18, 19, and 20. So let's position our guy right there. And let's just pretend he is stationary. He is not moving at all, okay? And when we press the space bar to fire our thrusters, what we're not going to do is we're not going to change the object's velocity. We're going to assume right off the bat the position is 0, all right? So the position is 0, and we're going to assume the velocity is 0. The object's not moving, right? Our probe, let me bring this back up here. Our probe is completely stationary right now. And when I press space to fire my thrusters, I'm not going to automatically give it some velocity. Instead, what those thrusters are going to do is give it some acceleration. So when we press space, we're going to set the acceleration. And I don't know, I'm going to set the acceleration to be +1. All right, so I'm going to set the acceleration to be +1. So what is that, what is that positive acceleration going to do for us? So right here, if our velocity is equal to 0, but our acceleration is equal to +1, on the next frame of motion, that acceleration is going to change our velocity. So on the next frame, our velocity is going to be 1. It's going to be +1. And what is that +1 going to do? It's going to move us, zoop, 1 space over. So we slowly moved over, but I'm still holding the thrusters. So let's say my acceleration is still +1. So now on the next frame, what is that acceleration going to do to my velocity? Well, I'm going to add 1 more to it. So now my velocity is going to be +2. So that's going to now move me in the next frame of motion, not 1 spot, but it's going to move me 1, 2 spots, and I'm speeding up. And that's where it gets powerful. My acceleration is still +1, so what's it going to do on the next frame of motion? Well, it's going to increase my velocity to +3. And now I move 1, 2, 3 spots. And so you can see how holding the thrusters is going to continually boost up our velocity. So we move faster and faster and faster, covering a greater distance. So now I'm all the way over here. But now imagine I let go of the thrusters. Okay, so now I let go of the thrusters. What is going to happen? Well, if I let go of the thrusters, I'm no longer going to have an acceleration of +1 anymore. In fact, what we are going to have happen is we could just drift at this speed forever and ever. We could do this. We could say, okay, if you let go of the thrusters, your velocity is 4. You're just going to keep moving at a rate of 4 spots. So the next motion, you're going to go 1, 2, 3, 4. And then the next motion, 1, 2, 3, 4. and so on and so on. We could do that. But what we are going to introduce is something called drag. Drag is something that is going to slow our velocity down. And to slow our velocity down, what we're going to do is we are going to have acceleration that is in the opposite direction of our velocity. And I'm going to make it small. So the drag's not like super noticeable. I don't know. Maybe I'll make the acceleration like negative, I don't know, I'll just say like negative 1.5. All right, so if my acceleration in the next frame, acceleration is negative 1.5. Let's change that correctly down here. So I'm going to change this to be negative now, negative 0.15. So that means on the next iteration of movement, I'm going to subtract 0.15. So now the velocity is not 4 anymore. The velocity is 3.85, positive 3.85. So we're actually going to slow down. So I'm not going to move all the way to 14. I'm going to move to be like right here. And then on the next frame, I'm going to subtract 0.185 or 0.15, and my velocity is going to be 3.7. So I'm going to move even less now. So I'm going to go 1, 2, 3, I don't know, I'll probably end up like out here. And then the next frame, we're going to move even less. And then the next frame, even less. And so that is known as drag. All right, we're going to have drag that is going to slow us down. So it all relates, these terms, position, velocity, acceleration, and drag. We are now going to implement them into our thrust and drift systems. So let's take these concepts and head back over to the computer screen and see if we can tie everything in together. So here we want to apply acceleration to the player's velocity. Okay, when thrusting, push the ship opposite the thruster's direction. All right, so if we look here, if my thruster is over here, right, on the left side of the ship, if I fire, I want the ship to move to the right, move rightwards. And if I'm over here with the thruster on the right side and I hit fire, I want to move the ship leftwards. Right now, with the thrusters on the bottom, I want to move the ship up. And right here, I want to move the ship down. But remember, when we accelerate, what are we actually changing? When we accelerate, what we're actually changing is the velocity. So we are going to target the player's velocity values here. So let's go look at our player object really quick. My player object has some properties here under our gameplay variables. It has an X and Y property, but it also has a Vx and a Vy. So we're going to target those velocities, the horizontal velocity and the vertical velocity. How exactly are we going to get those directions? Well, if you remember, the player has an Nx property and an Ny property. And those are the properties that we set way back in our first video in update thrusters direction. We said this is the portion of the arrow that points from the player to the mouse that is in the X direction, and this is that portion that is in the Y direction. So we have a reference of the positioning of this thruster. We just now want to fire in the opposite direction. So instead of adding, we are going to be subtracting. We're going to go in the opposite direction. So let's try to put all of that together into some really awesome lines of code. The first thing we're going to do is we're going to have our acceleration target the player's X velocity. So I'm going to type player dot, and we're going to get their Vx property. We want to go in the opposite direction, so I'm going to do minus equals, and then we actually have to get the direction of the thruster. The direction of the player's thruster is in player dot the Nx property. But that's going to get multiplied by the rate of our acceleration. So we got to figure out what is the size of our acceleration, because in our example here, I said, okay, my acceleration is going to be positive 1. I mean, I guess I could just put 1, but I don't know if that's what we want our acceleration to be. That sort of seems like something we should be able to tune, right? What our acceleration is going to be. So if I scroll up, we've got two variables here, thrust acceleration and drag. We're definitely going to work with these. So right now it's set to 0.5 for both of them. Let's use these variables, variables that we can finely tune in mission 3. So I'm going to multiply by thrust acceleration. All right, there's our first acceleration applied to the horizontal direction. Now let's mimic it for the vertical direction. So I'm going to say player.vy. We're going to get their vertical velocity, and I want to move in the opposite direction of the thruster. So I'll subtract, and I'm going to get the direction of that thruster, player.ny. And then we got to figure out what is the size of the acceleration. That's going to be in our thrust acceleration variable. Awesome. So let's take a look. Are we finally going to be accelerating across the screen? If I refresh the page, oh, I'm so disappointed. I get nothing. I get nothing. It is not fair. I'm using the acceleration to update the velocity. Why is it not changing? Well, if we come back here, we use the acceleration to update the velocity, but then we have to use that velocity to update the position, right? So we use the acceleration to update velocity. Now we use the velocity to update our position. So that is the next pivotal step. In fact, that is what mission 4, knock on wood, is exactly about. And look at that. It puts us in our update drift function. We know we're calling this every single frame of our game, and now we are going to move the player using the velocity values. So now we can update position based on our current motion. See, our acceleration updated the velocity. So now the velocity has changed, and now we use that velocity to update our position, just like we did on our whiteboard. Our player's position is found in their X and Y property. So I'll do player.x, and I want to move them in the direction of their velocity. Remember, we set the velocity opposite the thruster's direction, but now we want to move in the direction of the velocity. So I'll do plus equals player.vx. And then I will do player.y plus equals player.vy. So we're going to update their position by adding their velocities. Now let's take a look. Let's see what happens if we go to fire our thrusters. So I'm going to go right here. I'm going to fire. I should move down. Whoa! I zoomed right off the screen. I don't even know where I went. I don't even think I can get back. Let me hit R to restart the game. If I just tap, right? Ooh, I could just sort of like tap, and I'm going forever. I can go in the opposite direction. Whoa, this is not good movement, but it's pretty cool. I can fire myself in any direction, and then I can stop myself. All right, so this is kind of cool. Maybe you like these controls, but I absolutely don't. But the thrust system is finally working. We're zooming all over the screen. I hope you can hear it in my voice. I'm very, very excited about this. This is pretty fun. But again, oh, and look at that. I just go forever and ever. So if I tap this, there is nothing slowing me down. Remember, we said we were going to implement something known as drag. Remember, we said, okay, there's going to be some drag that we have that would slow us down, this negative acceleration or acceleration in the opposite direction of our velocity. We don't have that yet. So when we drift, we just drift forever and off the screen. I also think there's a big problem with our values, right? Our values here, we got to fix. But first, we'll add our drag force. So it says, apply drag to gradually slow the player. Reduce velocity slightly each frame. Okay, so what is drag right now? We had that set as a variable. Let's go back up to our student edit zone. Drag is currently set to 0.5, and it says the lower the value, the more drag you're going to get. So this is a decimal, right? So let's assume that we are moving at, oh, I don't know, what do we want to assume our velocity is at? Like 10, right? Like right now, let's just assume my velocity is 10. So if my velocity is 10, if I apply drag and I multiply by 10, 10 times whatever drag was, which was 0.5. Well, 10 times 0.5, let's pull up a calculator here. 10 times 0.5 would cut the velocity in half. It would cut it to 5. And then if I multiply by 0.5 again, it would cut the velocity to 2.5. And if I multiply the velocity by 0.5 again, it cuts it in half to 1.5. And you can see how each time I multiply by my drag coefficient or my drag constant, the velocity is getting smaller and smaller and smaller until it eventually is going to reach close to 0, and I'll become motionless. So I think that's what we want to do here, no matter what direction I'm going in, right? If I was going in a negative direction, let's just clear this, right? And I made my velocity like -8. If I multiplied by my drag coefficient, it's -4, it gets smaller. And then the next time it gets smaller, and the next time it gets smaller. So to apply drag here, all we're going to do is take the current velocity, player.vx, and we're going to multiply it, so times equals this sign, by our drag constant. So that is going to slow us down. If I just leave that, that's only going to slow us down in the x direction. That should be pretty funny. Let's see what happens. So if I shoot off like this, oh, I can't. That's crazy. I like can't even move horizontally. That's funny. Let's fix that and make player.vy also have some drag. So we'll do that as well. All right. So now we should get drag in both directions. So if I hit space, ooh, look at that. I stopped. So and I stopped. So that's pretty good. No matter what direction I'm moving, and I stop. But man, is that some aggressive stopping? This is just not fun anymore. I'm sad. I was so happy before zooming around the screen, and now I am extremely sad. And the reason why I'm extremely sad is because this new system is not yet tuned. So we have built the system, but now we have to tune the system. And that's where Mission 6 comes into play, because we have two constant variables in our student edit zone that we can use to finely tune how our game feels. Our ship is moving way too slow, and its drag is way too much. Now it says lower equals more drag. So drag is how quickly you're going to slow down. I'm slowing down way too much. So let's up this number. I don't know. Let's make it like 0.7. If that gets bigger, I should have less drag. Let's just see. Okay, I guess it's not really that noticeable. So let's make it even bigger. Let's make it like 0.9. Refresh the page. Okay, so that was better. That was better. Let's make it even bigger. I'm going to make it, I kind of messed around with this. I'm going to make it 0.9987. I'm just going to go out. I don't know. I just messed with those numbers. You can pick whatever you want. Whoa. Where did I go? I zoomed off the screen. It's probably because, oh, now this is kind of neat. I am slowing down. So that drift is actually kind of good. But I'm accelerating way too much. Way too much. Like my acceleration, I want to start slow. If you've ever seen a rocket take off, it starts slow and it takes a lot of time to build up some speed. So our acceleration is way too high at 0.5. I'm going to make it 0.017. Okay, 0.017. And I'll write 0.017. I like how that looks better. So now we have a very small acceleration. So it's going to take a lot of time for us to build up speed. If you think about it, right here in this first frame of movement, like we're not just moving one, we're moving like 0.1. And then the next one is going to be like, like what? We're moving like 0.017. We'll say 0.02. So then I'll move 0.04 and then 0.06 and then 0.08. I'm going to move more and more and more, but it's going to take time now. So let's see how this works. I start slow. I can move faster and faster. I can let go. All right. I can accelerate in the opposite direction. Ooh, this is kind of fun. I let go and I'm slowly slowing down, but it gives me time to reorient my thrusters and move in the opposite direction. So I really like how this feels. I have control, but it's still slippery, which is the kind of control I want for this space probe to fly around. So I can orient my thrusters in the correct manner. I still drift forward, but there's drag that is eventually going to slow me down. And I can also just lightly tap the thrust button to slow myself down if I want to. So I'm really happy with those numbers, and you guys can fine tune those so that they fit what you think feels good. All right, let's look at mission number 7. It says lose boundary. Add a margin around the screen for losing the game. Determine how far the player can drift off screen. All right, so let's see. Right now, it's set to 120 pixels. So let's just see. So if I go off the screen, let's see. If I go off the screen, zoop. Eventually, I want that to be a game over. So the question is, how far off the screen do I want to go? Because I should be allowed to go off the screen. Let's just see if I can do it. I should be allowed to go off the screen and then get myself back in. Can I do it? There we go. I should be allowed to do that. So I don't know. It's set to 120. I think actually in the final game I have this as 120. So let's just leave it at 120. I think that's what I left it as. So I'm going to keep it. So let's just leave it there. Maybe you want to if you want to change it to 100, maybe 100 better, or you want to give the player a little bit more leeway, a little bit more runway. We could set it to 200. Let's do that. We'll set it to. I want to keep it at 120. I'm going to keep it right at 120. And so now we have a lose condition. Once the player goes off the screen, it should be a game over. So we got to implement that lose condition. And so here is the lose condition. We had a function that we're calling called check if player is lost in space. And so if you look, what we're doing is we are asking a question that has 4 different checks in it, and they're all using or. So we're going to say, hey, is the player's X position, and the way we define the X position is the center of the player. Is that player's X position less than negative off-screen lose margin. So we just set off-screen lose margin to be 120. Well, 0 in the X position is right here. It's the left side of the screen. So now we're going to check to see if the player's X position is less than like negative 120 pixels. Basically, is the player over here? Or is the player's X position greater than the width of our screen plus our off-screen lose margin? Is the player's X position, here's the width of our screen, and then we add the off-screen lose margin. Basically, is the player over here in this area? If they are, then it's game over. And then we do similar checks in the Y position. So we check their Y position, and we check if it's less than the HUD height minus off-screen lose margin. So once they get to here and they drift into the HUD and beyond, it could be game over, and all the way down to the height of the screen plus that lose margin right here. If that Y value is greater, then it's game over. And only one of those things need to be true, which is why we use or. If this or this or this or this, then it is time for us to lose the game. And so how do we lose the game? Well, this is going to be our game states. So we're going to do, what is it? Our current game mode variable. We are going to assign it from our game mode object, one of our properties. We got 3 properties here that represent our game states. We have lose, play, and start. We are going to do lose. And if you notice, because we now have an actual lose condition in our game, I believe I got rid of our debug for game over. So in the key press function, we just have enter and R to restart. No more G key to end the game. All right, let's test out our fully functioning physics-based movement for space travel right here. So I'm drifting. All right, I'm drifting. Perfect. I'm going to drift off the left side of the screen. Psych, I'm going to apply my thrusters and keep surviving. And I'm holding it. Oh no, I'm accelerating too much. I'm speeding up. I lost control. I can't slow down. Probe is lost. I have fallen off the screen and our lose condition is active. I want to try again, so I just hit enter, and there my little probe comes back. So I'm really happy with how this is turning out. I think this was a roller coaster of highs and lows. I was really happy when I was moving all over the screen, and then I got kind of sad when that drag just slowed me down. But we fine-tuned those values, those parameters, right? The constants in our student edit zone that can affect how our game looks, plays, or feels. And we did a lot in terms of physics-based movement, applying changes to acceleration, which would then apply changes to our velocity, which finally in turn apply changes to our position. This is some really, really advanced movement systems, and you should feel proud of how you implemented them here in this video. In our next video, we'll continue to build on this because our acceleration, when we thrust, it's not for free. We can't just do it all the time. It's going to cost some resources, and we'll implement that resource system in our next video. So I'll see you then.